right, what we're going to talk about today is a quick BC review of polars and what we know about polars, polar coordinates, and graphs of polar curves. Okay, and so what we just need to do is get into the comfort zone again in dealing with r theta instead of xy. R theta instead of xy. Okay, so let's graph some points just to get our, remembering that this is r theta, let's get our bearings straight here to coin a phrase. Okay, so r theta, r is 6. Now just remember that this is the pole here instead of the origin, okay? And this is the polar axis. And this is the axis that shall not be named because this one doesn't really have a name. And these are in increments of pi over 12. So this would be pi over 12, 2 pi over 12, which is pi over 6, pi over 4, pi over 3, 5 pi over 12, and pi over 2. Okay, so just to refresh our memory. So the first and the last one are in twelfths. Okay, so the first polar point we're going to graph is we're going to graph 6, 7 pi over 6. So we're going to go out radially 6, 1, 2, 3, 4, 5, 6, and rotate 7 pi over 6, which means we're going to go all the way around and rotate to 7 pi over 6, which will be right here. And I'm going to make that a color on my graph here. So we'll make that's polar point A. You can't see it very well, but that's A. Okay? It kind of looks pretty in pink there. All right, polar point B. We're going to go out radially, 1, 2, 3, and then we're going to rotate negative 3 pi over 4. So negative 3 pi over 4, instead of rotating counterclockwise, we're going to rotate clockwise. So we're going to go negative 3 pi over 4. So we're going to go right into the middle, right here. Okay, well, let's make that a color. Let's make it blue. Right, B for blue. Blue for B, B for blue. Okay. All right, C. Now we're going to rotate out radially 8. I'll make this one brown. Radially 8, and we're going to rotate pi. So 1, 2, 3, 4, 5, 6, 7, 8. And rotate pi, which means I'm going to go all the way around and end up right here. And so this is point C. And then let's do D, which means I'm going to go out radially negative 6. So this is the positive part of the polar axis, and this is the negative part of the polar axis. So let's go out radially negative 6, 1, 2, 3, 4, 5, 6. And we're going to rotate 5 pi over 3, which is still a positive rotation. So it's going to go this direction, which is a little bit weird, I know. 1, 2, 3, 4, 5, 6. 5 pi over 3. So I'm going to hold this, and it's going to go all the way around, because this is going to be 4 pi over 3, and then it'll end up at 5 pi over 3. So we're up here. And this is D. Okay. All right, so let's do another point, E, which is negative 5, negative 11 pi over 6. Go out radially 5, 1, 2, 3, 4, 5. And negative pi over 6, which means I'm going to rotate clockwise, which is going to be awkward, but it's going to be all the way around, and then we're going to end right here. And so that's going to be E. Okay, so you guys do the next one real quick, and I will be right back. All right, how did your point F go? Let's see. The point is negative 4, negative 2 pi over 3. So let's go there. Let's do pink. Okay, so we're going to go negative 4, 1, 2, 3, 4, and rotate a negative 2 pi over 3, which means I have to rotate this direction, which feels a little bit weird, but this is clockwise. So this is 2 pi over 3, and then this would be 2 pi over 3. So we are right here, and this would be F. Okay, so this was just an intro to refresh your memory on how to graph polar points. Okay, and then to refresh your memory on how we transition between rectangular coordinates and polar coordinates. And I want you to remember what the 4 equations are that you need for parametric or polars, and that's going to be that x equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared. Or, I mean, similarly, r equals the square root of x squared plus y squared. And then, because this is kind of a, it comes out of this. And then what about theta? How do we find theta? Well, tangent of theta is equal to y over x. Remember our pillars of polars? This would be the first pillar, the second pillar, the third pillar, and the fourth pillar. And you got to watch out for what quadrant you're in here. So that's kind of a big deal. So we'll do some examples here in just a minute. All right, so the instructions say find the rectangular coordinates for each of the following polar coordinates. Well, what I like to do when I'm doing this is put r comma theta here so I know what quantity I have. And then where are we headed? We're headed to x, y. Okay, well, remember, on the unit circle or the non-unit circle, here we go, drawing it. What was our point here? If this was r. Yes? Hear someone softly saying it? Oh, yeah. It's r cosine theta, r sine theta. So sometimes I think going from polar to rectangular is a lot easier because this is just r and that's theta. And so this is going to be 4 cosine of 5 pi over 6, 4 sine of 5 pi over 6. And no, the unit circle doesn't ever go away, so we need to know what those values are. So that's 4 times, well, the cosine of 5 pi over 6 is, as you can see, I'm doing my hand here, is negative root 3 over 2. And the sine of 5 pi over 6 is, oops, I'm going to take away the sine here, is 1/2. Because that's a quadrant 2 angle. And so this is negative 2 root 3, comma 2. Okay, that would be our point in rectangular coordinates. All right, this next one's just going to be 8 cosine of negative 2 pi over 3, 8 sine of negative 2 pi over 3. All right, so negative 2 pi over 3 is a quadrant 3 angle, so they're both negative, the coordinates, and pi over 3, the point's 1/2 root 3 over 2. So this is going to be 8 times negative 1/2, 8 times negative root 3 over 2. And then that point's going to be negative 4 root 3. Okay? And that's x, y coordinates from r theta. All right, so next one we're going to do is we're going to find the rectangular coordinates. We were given the rectangular coordinates, and we're going to go backwards and find the polar coordinates. This is a little bit more challenging, but not difficult, okay? So this is x, y, and we need to go to r theta. Okay, so oftentimes I like to draw the point so I kind of have an idea in my brain where things are. So this is negative 3, which puts me in quadrant 4. And so let's find r, because r is just the square root of 3 squared plus, which is 9, plus negative 3 squared, which is 9. So it's root 18. Which is 3 root 2. Okay, and now I need theta. Well, theta can be as simple as, if I think about it, this is pi over 4, isn't it? This angle, because it's a 45-degree angle, because inverse tangent of 1 is pi over 4. So theta can be multiple angles. So we can go out radially, if we think about it, we could go out radially 3, and then we could go down pi over 4. So I could name it 3 root 2, negative pi over 4. That would be the easiest one to write. But this one says r is greater than 0, greater than or equal to 0, and it lies between 0 and 2 pi. So this one I can't write it in this way, but that's a possibility if I didn't have this restriction. So let's write it another way. I could go 3, outrightly 3 root 2, and then go all the way around, which would be 3 root 2, 7 pi over 4, right? And just for practice, let's name the other two, because this is the one that the problem is requesting. So we know that's the answer. All right, well, I could also go out radially negative. So I could say negative 3 root 2, and then I could rotate in the counterclockwise direction, which means it would be positive 3 pi over 4. Or I could say negative 3 root 2 and then go in the negative direction, and that would be 5 pi over 4. Right? Because remember, counterclockwise, going this direction is positive, going this way is positive, and going this way is negative, which is a little bit strange when we're dealing with polars. All right, let's do another one. Number 5. Let's draw it really quickly. This is going to be in quadrant. I'm going over 5 and down negative 5 root 3. So it's going to be in quadrant 3. So this is negative 5, negative 5 root 3. Okay, so r is going to equal the square root of, well, I squared the first one, which is 25, plus squaring the second one, which is going to be 25 times root 3 squared, which is 3. So that's going to be 25 plus 75, which is root 100, which is just 10. All right, and now I need to find the angle. So I'm going to say alpha equals inverse tangent of y over x. So it's going to be, and it's got to be the positive ones, right? 5 root 3 over 5, which is inverse tangent of root 3, which happens to be pi over 3. So alpha is pi over 3. Okay, now they want our r to be negative and to our angle to be between negative pi and pi. So over this direction here. So we want a negative r, so let's make our r negative, which would be negative 10, which means I'm starting out radially on the polar axis on the negative direction, and then I'm going to rotate, it looks like, counterclockwise, a positive pi over 3, and I think that would be the answer. Okay, but theoretically we could name this point three other names based on which way we started and all of that. So that's just a quick refresher on how to change from rectangular to polar and from polar to rectangular. All right, so let's go to page number 2 in this lovely packet. Okay. Hopefully you're having some nice positive flashbacks from polar. Okay, let's do another one. This is number 6, which is part of the, we're going to change this from, this is XY, and then we're going to polar mode. So we're going to r theta. So the first thing I do is plot to see where I am. Well, this is 4 root 3 up 4. So we're in quadrant 1, and let's figure out what r is. Well, r is the square root of, that's going to be 16 times 3 plus 16, which is, let's see, root 48 plus 16, which is really nicely in our case 64, which means r is 8. That's great. All right, and let's figure out what alpha is. Alpha is going to be inverse tangent of 4 over 4 root 3. Which is inverse tangent of 1 over root 3, which happens to be inverse tangent of root 3 over 3, which is pi over 6. So it's the pi over 6 angles. Now our restriction here is that r is going to be negative, so we're going to start over here and then rotate over to here. So our r is going to be negative 8, comma, and our angle is going to be between 0 and 2 pi, which means it needs to be a positive angle, which means I'm rotating counterclockwise. So I need the pi over 6 angle. So this would be pi over 6, 5 pi over 6. This would be 7 pi over 6. Oops. I need to write better so y'all can see it. All right, so 7 pi over 6. All right. The next part is where we change our polar equations into rectangular equations. And we have to use our 4 pillars of polars, okay? And what we do here is we square both sides. Why do I do that? Because r squared is equal to 64, right? But what is r squared? Remember, what are my pillars of polars? I'm going to put them over here. We have x equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and there's a corollary that comes off of that. And then theta equals inverse tangent of y over x, or tangent of theta equals y over x. All right, so if r squared equals 64, that means that x squared plus y squared equals 64, right? And that's a circle of radius 8. And that makes sense, right? Because if we go back to our polar graph, which I will pull over here. If you go back to your polar graph, circle of radius 8, right? That's just going to be that r is constantly 8, so it'll be a circle of radius 8. Makes sense to me. All right, let's do this next one. All right, well, number 8 says r cosine theta equals 6. Well, where have I seen this before? Well, lo and behold, r cosine theta is x. So this is x equals 6. Done. This is a vertical line. Wait, I'm going to say this is a circle. Radius. Oops, radius. S is an 8. Radius equals 8, and the center here is 0, 0. This right here is a vertical line. X equals 6. All right, next one's a little bit trickier, but not that much. Number 9. R equals negative 5 cosecant theta. Now, I don't have a pillar or polar here that is got anything to do with cosecant. So I'm going to change the cosecant to what I know it to be true. So R equals, this is going to be negative 5 times 1 over sine theta. Because remember, cosecant is 1 over sine theta. Okay, and then I'm going to multiply both sides by sine theta. And I get R sine theta equals negative 5. And there I see another pillar of polars, so that's just y equals negative 5. And that's a horizontal line. Okay, let's try this next one. This one's a little bit more challenging. So what I do is I multiply everything by r. Now the reason I do that, both sides by r, is because if I multiply by r, I'm going to get r squared here equals 7r sine theta. And I know what this is here. This is y, and this is x squared plus y, right? X squared plus y squared. So we get x squared plus y squared equals 7y. And now this is a circle that needs to have its square completed. So we can say that this is x squared plus y squared minus 7y equals 0. And then I'm going to complete the square here for the y, because the square is already completed for the x. So that's going to be x squared plus y squared minus 7y, and I have to take half of negative 7, and that's going to be 7 halves. And I square that, and I get 49 over 4 equals 49 over 4, because what I do to one side, I better do to the other. So I add that, and then I'm going to use my lovely little arrow to go back up to the top here and say, okay, well, then that's going to be x squared plus y minus 7 halves, because whatever's being squared is what goes That's the perfect square, or you could factor this if you wanted to, equals 49 over 4. And there is another circle with a radius 7/2, because you take the square root of this, and a center of 0, 7/2. Okay, and so that would be our equation. All right, so what are we going to do when we find we're going to change the rectangular ones into polar coordinates? Okay, and so typically what we like to do here is get r equals something or theta equals something, if we can do it. Okay? All right, so x squared plus y squared equals 81. Well, hopefully you're remembering that r squared equals x squared plus y squared. So we can just make a straight up substitution here and say r squared equals 81. And we can take the square root of both sides and get r equals 9. Now, you could say r equals plus or minus 9, but let's talk about that. If you're going out radially, 9 and making a circle, or negative 9 and making a circle, does it make a difference? No, and we may as well remain positive. Okay, and so obviously this is a circle, radius 9. All right, let's do this next one. Y equals negative 5, which happens to be, what we did here. So we're going backwards. We're going to say r sine theta, because that's what y equals when the pillars are polar, equals negative 5. R equals negative 5 over sine theta, and then we know 1 over sine theta is equal to cosecant theta. So there we go. We went backwards. All right, next one. All right, so on these, what I like to do is plug in for what y is. Well, what is y? Y is r sine theta, and x is r cosine theta. So let's make those substitutions. So y squared is going to be r squared sine squared theta. And I'm going to move the 10 over. So minus 10r cosine theta equals 0. Okay? So all I did straight up was to substitute in for y squared, substituted for y and square it, and then plugged in for x. And now I'm going to factor out an r. And you'll see why I'm going to do that in a minute. Okay, so we get r sine theta minus 10 cosine theta equals 0. So r sine squared, I'm sorry, this is sine squared. Can't forget the square. Okay, now, what happens now is I have two possibilities. I have r equals 0, or I have r sine squared theta minus 10 cosine theta equals 0. Now let's talk about what r equals 0 is. That means I have no radius, which means this is the pole. Okay, so that's really not a curve. That's just a point. It's a pole. So we're going to take this one and solve for r. Okay, how do I do that? I'm going to move the 10 cosine theta over. So we're going to get r sine squared theta equals 10 cosine theta. And then r squared, I'm sorry, not r squared. R equals 10 cosine theta divided by sine squared theta. And we could simplify this because cosine over sine is cotangent. So we can make it cotangent theta, cosecant theta. Just makes it prettier without any, fraction. Okay? All right, let's do this next one. 3xy. Well, I'm going to substitute directly in for x and y, and so we're going to get 3 times r cosine theta times r sine theta, that's what y is, equals 7. And then we're going to multiply it out. And we're going to get 3r squared cosine theta sine theta equals 7. And I have to solve for r. Okay, so let's do that. I'm going to say r squared equals 7 over 3 cosine theta sine theta. Okay, and then r equals plus or minus the square root of 7 over 3 cosine theta sine theta. Okay, now you might be asking, well, gosh, what does that look like? Well, this right here, believe it or not, is a family of hyperbolas. This is a hyperbola. And I do have Desmos open just on the off chance that we might want to see what one of these looks like, okay? So let's do this. Let's say r equals the square root of, what is it, 7 divided by 3 cosine of theta. Whoops, I can't type theta. There it is. I'm lost without my driver. Right? And so it is a family of hyperbolas. And so really, how do I know it's a hyperbola? I know this is a hyperbola because if I were to solve for y, we would get 7/3 times 1 over x, right? And that's a hyperbola because that's like a power function, right, with the -1 exponent. So you really, and you notice that when we did it on Desmos, that you can have it just plus and you get the whole curve. So this is r equals the square root of 7 over 3 cosine theta sine theta. Now, would I expect that you know that this just looking at this, hold on, it would help if you could see my screen, right? Would I expect that you know this right here is a hyperbola? No. But I would hope that you would know what this graph looks like and know that that's a hyperbola, knowing this. Okay? All right. Of course, we didn't look at this one. Let's look at this one. This would be kind of cool to look at. All right, so let's see what we can get when we do that one. I'm going to hide this one. And we're going to say r equals 10. That's a pretty big circle. Cotangent. Theta. Ooh, that's fascinating. Cosecant. Theta. Oops. Okay, there we go. So that looks like a parabola. But did we expect that? I'm going to say we did. Whoop, you don't need to see my email, right? Oops. It helps if I do this. That looks like a parabola, doesn't it? Well, of course it does, because this equation is a sideways parabola. Nice, put this one here. I'm going to close these so we don't have that issue again. Okay? All right, let's move along. Now I'm going to move to page 3. Okay, and I'm not going to do the conversion to polars and all that because we've done that already. I'm not going to convert these. We've done that already. I'm not going to convert these. So I'm going to move on to number 7. Okay, because this is where things get a little bit more interesting. It says identify the polar graph as a circle with center at the pole, circle with the center on the x-axis, circle with the center on the y-axis, a line through the pole, spiral out, spiral in. Okay? All right. So what I like to think about is this is a cosine, right? So this is a cosine. And so this, if I were going to graph this, if we were to change this to polar form, what would we do? We'd multiply everything by r, right? And we get r squared equals 16 r, I'm sorry, try again. Minus 4r cosine theta. Right? And then this would be x squared plus y squared equals negative 4x. Okay, so right here, I know this is a circle, and the shift is going to be in the x direction. So this is a circle with the center on the x-axis. Why do I know that? Because if I were to complete the square, I'm completing the square only on the x. So I know it's going to be shifted left or right. And I know it's left because this is negative. Okay. R equals 4. Well, let's think about that. That's x squared plus y squared equals 4. So this is a circle with the center at the origin. Well, at the pole, right? If we're going to be accurate. Theta equals pi over 4. Theta. Okay, that means theta equals inverse tangent of y over x equals pi over 4. Now, how do I get the y over x all by itself? Well, we take the tangent of both sides and we get y over x equals the tangent of pi over 4. Well, what is the tangent of pi over 4? The tangent of pi over 4 is just 1. So I get y over x, oops, excuse me, division. I get y over x equals 1, so y equals x. So this is a line that passes through the pole. R equals negative 40. Okay, let's think about that. That means I'm going out radially in the negative direction, 40, and then my radius is always 40. So this is a circle with the center at the pole. I hope that makes sense to you. All right, so this is r equals 4 sine theta. If I were going to multiply this equation by r, I would get r squared equals 4r sine theta, which is x squared plus y squared equals 4y. And if I were to complete the square on this, the x is already complete, and the y I'd have to complete. So that means the y is going to be shifted up or down. So this is a circle. Can I spell circle? No. With the center on the y-axis, or the axis that shall not be named. All right. Wow, this is r equals 4 over theta. Now, how I like to think about this is if theta is really small, or let's try it this way. If theta is really big, here's my polar plane. If theta is really big, what is r? Well, r is 0. What happens when theta is really small? Like, 0. Well, I can't divide by 0, right? That means r is huge. So I believe this is a spiral in. Because when theta is 0, r is huge, right? Because if I'm rotating out, theta is 0. I can't divide by 0, but 1 over something very large, 1 over something very small is very big. So it's going to be out here somewhere, and it's going to spiral in. But I'll prove it to you. Here we go. So we're going to say r equals 4 divided by theta. And there it is. So you see what I'm saying is it spirals in. And we could keep going and going and going. But what's happening here is when r is equal to, when theta is equal to 0, which is on this, right? Because that means when theta is 0, this is where my angle is, because that's theta equals 0, right? Because this is theta equals pi over 6. So when theta is 0, 4 over something very small like 0 is huge. So it starts way out here and then spirals in. Okay? That's pretty cool. We like to look at spirals and conch shells. All right, just a refresher on those. Okay? All right, now we're going to go to let's see what the next page is. I want to do page this one here. You can't see it. which is not very helpful. There we go. All right. That's the 5th page in, I believe. All right, so that's where we're going to actually start graphing these. So we have to remember how to graph these things, which is not difficult. And I'll post my graphing polar functions, but I don't think you'll need it. So the very first thing I do personally is that I think about what the r theta curve looks like. Here it is. What do I mean by that? This is theta, and this is r, and then my midline of this function is 3. So I'm going to go to 3, put my midline, and my amplitude is 3. So I'm going to go up to 6 and down to 0. Okay, and this is a cosine. And the period is not changed, right? Because the period is just 2 pi because there is no stretch factor horizontally. All right? 3 pi over 2. Okay, so cosine starts off the midline and up in amplitude. So up here, I'm going to start up here. And then I'm going to go back to my midline, then down in amplitude, back to the midline, and then up. And we remember graphing these. You guys were really good at that. I know you were. There you go. And remember, please, that this was r and this was theta. Okay? And I want you to think radially than theta, right? Because, and this is a little bit weird because we're usually doing x, y here when we do this, but we're going to, when we plot polar points, we need to think radially and then rotate. Okay? So I want you to look at the r factor here. What's r up here? R is 6. And what is theta? Well, theta is 0. Okay? All right, so let's plot that point. 1, 2, 3, 4, 5, 6, 0. I'm not rotating at all. The next r is 3 at pi over 2. So I'm going to go out radially, 1, 2, 3, and I'm going to rotate pi over 2, which means I'm right here. Okay? And then I go where? Well, what is this? This right here, my friends, remember, is the pole. Right? So we're going to go to the pole. So, but what is r doing? R is getting smaller until it goes to the pole, right? So what's going to happen is r is getting smaller until it gets to the pole. Here it is. Is r radially getting smaller? The answer is yes. Okay. Then what happens after we leave the pole? I'm going to go to the point 3 pi over 2. So I'm going to go out radially 3, 1, 2, 3, and rotate to 3 pi over 2, which is right here. And then I go back again to 6, 2 pi. So I'm going to go out to 6, rotate 2 pi, and it brings me back home. So I'm going to bounce off the pole. Yeah, that looks, you know, I can't worry about making it a perfect cardioid. Right? It's a perfect cardioid. Very nice. And it bounces off the pole because our graph bounces off the pole here. Do you see that? That's correlation. And it's going to bounce off the pole when these two numbers are the same. But I don't want you to have to memorize that. But that's a cardioid. And you notice that it's on the right side of the polar axis, the big part. And this is a plus. If it was negative, it would be on this side of the polar axis. All right, so let's do another one. This next one is r equals 4 minus 4 sine theta. So I already know it's a cardioid, right? Because these two numbers are the same. And I'm going to graph my point, or my curve. And I have no horizontal shift, or stretch or shrink. So I know it's 0 to 2 pi. And my midline is 4. And so my amplitude is 4, so I'm going to go up 4, which is going to put me at 8. And I'm going to end at 0. Okay, and here's my midline. There it is, really quickly. All right, and then sine starts on the midline and then goes down in amplitude, right? This is pi over 2. 3 pi over 2. Sine starts on the midline, goes down in amplitude, back up to the midline, up in amplitude, and back down to the midline. There we go. Nice. And I'm not going to do an r theta table here because I want you to just read it off this graph, okay? So r is 4, so I'm going to go out radially 4. 1, 2, 3, 4. Okay, and then I'm going to rotate 0. Then what happens? Where do I go? I go to the pole. And r is getting smaller, isn't it? It sure is. And I know that this is the small part, and this is the small part, because this is the big part of the curve. So I'm going to go to the pole. So it's going to go from here to here. And I know it's a cardioid, and I know it's going to bounce, but let's prove it to ourselves. The next r is 4, and I'm going to go out radially pi. So 4, and I go out radially 1, 2, 3, 4, pi. So there we go. So we bounce off the pole, and then my next point is going to be I go out radially 8. So that's 4, 5, 6, 7, 8. And I'm going to go 3 pi over 2. So I'm going to end up down here. So 8 right here. So there it is. And I'm going to go back home again, right? And that's a cardioid because that bounces off the pole. All right. I knew that this was going to be symmetric with the axis that shall not be named because this was a sine, and I knew it was going to be underneath because this is negative. If it was a positive sign, it would be up here. I know you're having great flashbacks of this. All right, let's do another one. Here we go. This one's going to be cosine. Its midline is 4. And it's not shifted horizontally, and it doesn't have a nice stretch factor, so my period is 2 pi, which is really nice here when we're getting reacquainted. Okay, and my amplitude is 6, so I'm going up to 10, but then I'm going down to negative 2. And this is a cosine. Can you tell me which side of the axis it's going to live on? Well, this is a plus, so it's going to be like this one up here. So it's going to live on this side. The larger part's going to be on the right side of the polar axis. Okay, cosine starts up in amplitude off the midline since it's positive, and then it goes back to the midline, down to negative 2, back to the midline, and up again. And here we go. Here's our cosine curve. All right, and now I'm going to go out radially 10. I'm going to go out radially 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and rotate nothing, right? Because our theta is 0. Then I'm going to go out radially 4 and then rotate to pi over 2. So 1, 2, 3, 4, rotate to pi over 2. And then what is this? Danger, danger, Will Robinson, right? What is this? There's the pole and there's the pole. So I got to know what value that is. But what's going to happen is I'm going to pass through the pole, right? And then I'm going to go to negative 2 radially, 1, 2, and then rotate pi, which means positive pi means I'm rotating here. Okay, so I'm going to have the big part of my curve here, and then I'm going to pass through the pole, and end up here. So I'm going to pass through the pole. Whoops, that was kind of awkward. Pass through the pole and end up here. Not a beautiful curve, but that's the best we're going to get at the moment. And then I have to pass through the pole again to get to my next point. But my next point is going to be radially 4, 3 pi over 2. So it's going to be down here. So 1, 2, 3, 4. So I have to pass through the pole and end up down here. And then I go back home again when I hit 2 pi. So this one right here is a limacon with an inner loop, right? Now, the next time I get to talk to you, we're going to be finding the area of these enclosed by these shapes. And so we need to know what the intervals are for this inner loop. And I know that we did this last year, but let's refresh our memory. How do I figure out what the angles are that create this inner loop? Well, I know when I'm going to pass through the pole. So I have to set this equal to 0 to figure out when I'm at the pole. So you're at the pole when you can say 0 equals 4 plus 6 cosine theta. Okay, so I'm going to say 6 cosine theta equals negative 4. Cosine theta equals negative 2/3. Cosine is negative in quadrants 2 and 3, and I need to find alpha. Inverse cosine of 2/3. That's going to be the positive angle. Right here I have my handy dandy calculator right here ready to go. Clear. Let's F18. Let's make sure you're in radians because calculus is rad. Okay, and we're going to go second inverse cosine of 2 divided by 3 and diamond inner, and we're going to get 0.78. Did I do that right? I did the cosine. I'm like, wait a minute. Inverse cosine. Never a dull moment. 2 divided by 3. There we go. What do we get? Oh, nice. Nice. Diamond inverse cosine of 2 divided by 3. Yeah, that didn't help me very much, did it? So I'm going to diamond approximate so I can get the number. What is that? 0.841. You know, every time I try to do one of these things perfectly, it just never happens. So 0.841. All right, but that's not theta, is it? No. I've got, this is theta, and I have theta 2 here. So I'm going to say pi minus, second pi minus alpha, which is my answer. So I'm going to go second answer. And that's 2.300. Or 2.301. And the second theta is going to be pi plus that. So I'm going to grab this right here, clear this, and second pi plus, go up here, grab my answer, and we get 3.93. 3.93. No, 83. 83. My eyes are going bad. Okay, so let's see if that makes sense with our graph. Okay, so pi over 2 is about 1.57, and pi is 3.1415. And so 2.3 is definitely between those, so I feel good about that one. 3.9, pi is 3.14. 3 pi over 4 is about 4.71, and this is definitely in between. So the inner loop interval is 2.301 to 3.983. Okay, so we need to be able to do that because we're going to be finding the area that is swept out by the angles for the inner loop and all this other stuff next time that we talk. So that's great. So this is a limicon with an inner loop. All right, let's do another one. This one is 7 minus 2 sine theta. 7 minus 2 sine theta means I have a midline of 7. Here it is. Here's my midline. And my amplitude is 2. So I'm going to go up to 9, and I'm going to go down to 5. Okay. And my period is 2 pi still, because we're starting off nice and basic. Now, what are we going to notice? You see, this one hit the pole twice. What's this one going to do? Well, my friends, since the amplitude is 2, it's never going to hit the pole at all. And of course, I chose one where the sign is negative, so it's going to go down the amplitude first. I should have done, you know, ones where I had one negative cosine, but that's all right. We're going to live with what we got. All right, so let's graph some points. R is 7 out radially 7 and rotate nothing. So 1, 2, 3, 4, 5, 6, 7, rotate nothing. And then I'm going to have my radius of 5. 1, 2, 3, 4, 5, rotating pi over 2. And then I'm going to have my radius at 7 again and rotate pi. So 1, 2, 3, 4, 5, 6, 7, right? But I'm 7 and then I'm rotating to here. And then I'm going to have a radius of 9 and I'm going to be down at 3 pi over 2. And then I go back home. Okay, so this one is a dimpled limison because I don't go back to the pole, do I? So dimples just a little bit. Probably bows out a little bit more than that, but. And it's dimpled, and I knew that the bigger part or the non-dimple part was going to be down here because this is a negative sign. Okay, so I hope that refreshes your memory a little bit on graphing cardioids and dimpled limicons and limicons with an inner loop. Okay, now the fun begins. Okay, next one we're going to do let's see here. Number 13, if that's all right. You'll have to flip around for this one, but this is simply r equals 6. So r equals 6 is what? A circle with radius 6? 1, 2, 3, 4, 5, 6. So it's just going to be a nice circle with radius 6. Right? Very nice. And it's certainly not a one-petaled rose. But anyway, okay. All right, what about this one? This one here? Theta equals negative 5 pi over 6. So this means for all time, no matter what r is, theta will be negative 5 pi over 6. So no matter what r is, so let's say r is 2, 1, 2. What's negative 5 pi over 6 from here? Well, it's going to be over here. So here we go. Negative 5 pi over 6. Let's say r is 3, or 1, 2, 3, 4, 4. It's going to be negative 5 pi over 6. Boom. Okay, so do you see how this is just going to be a line? And we could have called this line theta equals pi over 6. That would be equivalent, right? So that's just a line. Okay, next one. I'm going to do this really quickly because this midline here is 0, right? Amplitude is 6. Go into 2 pi. Pi over 2. Okay, and this is a cosine curve, so it's going to do this. I think everybody knows. Okay, so keep going, obviously. So out radially, 6. 1, 2, 3, 4, 5, 6. There it is. And then I go to the pole, pi over 2. Go to the pole. So what's happening here is r is getting smaller as I go to the pole. So here it is. R is getting smaller as I go to the pole because I'm curving in. You see how r radially is getting smaller? And then what happens? I go out to negative 6. 1, 2, 3, 4, 5, 6. And rotate pi. So I'm ending up here. So I only need half of the period to graph. This is a circle. And we knew this was a circle because of the changing the equations that we did. So that is a nice little circle, but it's on the polar axis because it's cosine. Okay? Now, I want you to notice, please, that this right here, this 6 is the diameter, not the radius. Right? Because we went out radially 6. Okay, r equals negative 4 sine theta. I want you to project, if you will, where it's going to be. Is it going to be up here or down here? Oh, yes, everybody said down here. And what's its diameter going to be? Well, it's going to be 4. 1, 2, 3, 4. And it's going to hit the pole and all that. And we could prove that, but this is how you do that. You would say 2 pi, 0, and then pi. And then the sine curve, right, going between -4 and 4. And we're going to go down and back up and then down again. And so you'd start at 0 at the pole here. And then you go down -4, 1, 2, 3, 4, rotate. This is pi over 2. Rotate pi over 2 to bring you here. And then you go back to the pole. Boom. There you go. And you only need one period to graph this one too. All right. All right. So I'm going to have you pause the tape or the video and you graph this one really quickly. You mark, set, go. Okay. You're back. Theta equals 3 pi over 2. That means for any r, your angle is going to be 3 pi over 2. So at 1, it's going to be 3 pi over 2. At 2, it's going to be 3 pi over 2. At 3, it'll be 3 pi over 2. Let's see if it works for the negative numbers. At -2, it'll be 3 pi over 2. Oh, yes, it does. Look at that. It's the y-axis. This is a fancy name for the y-axis. All right. This is r equals -5 over theta. Now, we did 4 over theta. And that came spiraling in from out here. So what are we going to guess this one's going to come spiraling in from? From out here, I bet. Okay, so let's do something nice. Like theta equals 1. Theta equals 1. So I'm going to go out radially, -5. 1, 2, 3, 4, 5. And theta equals 1. Well, that's, 1 radian, which we know is almost about 60 degrees, right? 57 point something. So I'm going to put a point right here. Okay. And then what happens when, let's do theta equals 5. Because that'll be -1, right? So it'll be here, -1. And theta equals 5. Well, 5 is not quite 2 pi, but it's greater than 3 pi over 2. So I think we're going to be over here somewhere. So what's happening is this is going to be coming in like this and zooming in. Okay? You don't really have to draw many spirals by hand, but we can prove it to ourselves here. Let's do it. Let's make this -5, not 54, right? That would be hilarious. But do you see how when I came in right here, I did this point and then I came spiraling in? This point is spiraling in, but I guess it goes out this way and around. So I fixed mine. Sorry about that. So it's still like this. Fascinating. But it's spiraling in. The other one that we had, I forget, came spiraling in this way, I think. Or I don't remember. Anyway, I want to keep going so my video is not 100 hours long, okay? And I'm going to do just 2 more so that you guys can remember how to graph roses. We need to graph roses because we like to end with roses. Roses are such a fun thing. Okay, so this complicates things a little bit because my period is no longer 2 pi. It's 2 pi over b, and b is now 2. So my period here is equal to pi. Period is pi. Okay, and this is a sine curve, and it's an even number. So what does that mean? We're going to have how many petals? Even numbers means we have double the petals. So we're going to have 4 petals here. Okay, so we're going to go to pi, and then I'm going to have pi over 2 in the middle, and this is pi over 4, and then 3 pi over 4. Of course my phone rings right in the middle of my lovely little dissertation on roses. And I'm not answering it because I don't know the number. Oh well, here we go. Sine, it has an amplitude of 6. So it goes up here. Of course it'll ring 12 times. But life happens. All right, so we're going to start. Sine is a sine curve with the midline at 0. Starts on the midline, goes up in amplitude. It's really scrunched in here. I know, I'm sorry, but calling back? No, they're not. I guess they are calling back. I don't know the number, or I would pick it up, but we're just going to let it go. If you guys can help me let it go. Never a dull moment. Okay. My radius is 0, and my angle is 0, so I'm starting at the pole. Okay. Now what's really cool is this is my petal length here is 6. So all my radially going out at pi over 4. Okay, so 1, 2, 3, 4, 5, 6, and I'm going to rotate 2 pi over 4. There we go. And so I'm going out to 6, and then I'm going back to the pole. Remember, because anytime you're on the theta axis here, you're at the pole. Okay, and then we're going to go back to the pole, right? Because we went back to the pole. Now I'm going to go out radially -6. 1, 2, 3, 4, 5, 6. And then I'm going to rotate 3 pi over 4. So 3 pi over 4 is a second quadrant angle. So I'm going to be in the middle one here. 1, 2, 3, 4, 5, 6. Okay, so I'm at 6. I'm going to rotate 3 pi over 4. Okay, but I'm passing through the pole. So I'm passing through the pole to the petal length, and then I'm going back to the pole. Here we go, going back to the pole. All right, and then I'm going to rotate out radially 6 again, and then rotate. This is going to be not 3 pi over 4, but 5 pi over 4. So if I'm out here, 5 pi over 4 is going to be right about here. And once you get the symmetry, you know, it's really cool how you figure out that it's going to be symmetric. Okay, and then you go back to the pole, and then we're going to go out -6, -6, and then this is going to be 7 pi over 4. So we're going to go 7 pi over 4, which puts us in the middle right here. So we're going to go through the pole, out again, and then back again. And there's our 4-petaled rose. All right. Very nice. Now cosine. Now this is not a nice one here, because this period here is 2 pi over 3. And I'm sorry about that, but here we go. We got to do at least one. Okay, so if the period is 2 pi over 3, the increment is 1/4 of this. And 1/4 of 2 pi over 3, 2 pi over 3 times 1/4 is equal to 2 pi over 12, which is pi over 6, which means the increment is pi over 6. Okay, and so the period is 2 pi over 3. That's going to be equal to 4 pi over 6. So we're going to go to 4 pi over 6. 4 pi over 6. Halfway is 2 pi over 6. This is pi over 6. And this is pi to 1, 2, 3. This is 3 pi over 6. And this has got a midline of 0 and an amplitude of 7. -7. And cosine is negative, so it's going to start off down in amplitude to the midline, up in amplitude, down to the midline, and then back. Here we go. There we go. There's our cosine curve. And then we're probably going to have to do another one, because this is half a petal, this is a petal, and this is half a petal. But maybe we can see the pattern. So I'm going to rotate out 7 radially in the negative direction. 1, 2, 3, 4, 5, 6, 7. And I'm going to go 0. And then what happens? Oh no, I'm going to the pole. But we knew that, right? Because these are petals. So I'm going to go back to the pole. And then where do I rotate? This is pi over 3. So I'm going out 7 radially. 1, 2, 3, 4, 5, 6, 7. Wait. 1, 2, 3, 4, 5, 6, 7. And I'm going to rotate pi over 3 radially, which is right here. So I'm going through the pole, going to rotate radially pi over 3, and then I go back to the pole. There we are, back to the pole. And then I'm going to go -7 and rotate, and that's 4 pi over 6 is the same as 2 pi over 3. So I'm going to rotate to 2 pi over 3, which is going to be, this is 7 in the positive direction. This is 2 pi over 3. So we're going to rotate, go through the pole, rotate to here. And I bet you can finish the rest of it, right? Because it's going to come back to the pole and then pass through and do this. And this is a 3-petal rose. Now, it's a 3-petal rose. Do you notice that the cosine is splitting the polar axis on the left side? That's because it's negative. If it was positive, it would split the polar axis on the right side. Okay? So that's the only difference there. And it's a 3-petaled rose because this is an odd number in here. And there you have it. So I hope you've enjoyed our tour of our review of polars from last year. And have fun, with the homework. And we will talk to you next time. And have a great afternoon.